Perfect. So yeah, as you said, this is an acronym-laden talk. I apologize. So what we're doing is we're reversing NTLM version 1 to NTLM, which is basically a legacy authentication protocol written back in Windows 2000 era. But before that, the bio slide, because we all have to go stroke our egos somehow. So I'm EvilMog. I'm a chief architect of X-Force. I collect black badges. I've got like 5 of them from various places. Don't ask how. I'm a quasi-retired member of Team Hashcat because I don't show up to the contests anymore. I'm a former sailplane pilot because screw Transport Canada. Special effects pyrotechnician because I like to blow things up. I'm a bishop of the Church of Wi-Fi. Don't ask about the paddle. And I play a lot of Hacker Jeopardy, as certain people in this room can attest to. DFIU. Oh yeah, also, this talk, before we get into it, will be slides followed by live demo, and I don't have any backups, so if I screw it up, you're allowed to throw foam balls at me a la Shmookon. So I believe in living dangerously. This is how I get alive. I used to deliver this talk 100% for the slides from the catting in the terminal, but I had to do a proper slide deck for the Japanese, so you're getting my Code Blue talk instead, which is slightly more production value. I apologize. So, Windows password storage, and yes, I apologize for the really tiny eye chart there. When you dump a hash from a Windows domain controller, you basically get a user ID, a relative identifier, an LM hash, and an NT hash. The NT hash is basically 16 bytes. It's effectively MD4 run through UTF-16 little endian encoding. Which has an interesting side effect in that if you have a 128 character password of, say, a domain controller machine account, all it is that gets converted down into a tiny NT hash. And in Windows, NT hashes are password equivalent. You don't actually need to know the password, you need to know the NT hash. The cool part about this is this also applies to MS-CHAP v2 when you're authenticating to a wireless network. If you know a computer account hash, you can actually authenticate to a PEEP MS-CHAP v2 wireless network. Cool little fact. We'll abuse that here later. So, some common NT hash types for those that don't know. There's LAN Man, which is DES-based, super fast in Hashcat, Hashcat mode 3000, and it is so deprecated it's not even funny. If you see it there, you can crack the passwords in like 2 minutes from a CPU running on like a T60 from 2009. It's ancient, don't use it. Here's the thing though, it was created back when cryptography was illegal. You couldn't do export-grade encryption, which is why we had the weak encryption. Yeah, thank you. That's why we have all these ancient things built in. It's not Microsoft's fault. It's the U.S. government's fault. And being a Canadian, well, I mean, that gets entertaining. So anyways, there's also 2 different hash types. There's NetNTLM version 1, which is DES-based, and there's NetNTLMv2, which is, if I'm remembering this correctly, RC4HBAC. If I'm remembering this correctly, there's HBAC MD5 base, sorry. So that's basically a challenge response. And so the next slide, here's how it works. So say you're a client, you send a login request to a server sends a challenge back to you, you take that challenge, you send back a response. This is super high level. We'll get into the details here, which is going to either put you to sleep or get you excited, depending on how much of a math nerd you are. So, basically how this works is clients can send a negotiate message. This has, all the various flags you need to set and what it supports. The server's going to respond with a challenge message packet containing an 8-byte random number, which is basically the server challenge. The client then encrypts that server challenge with the NT hash, otherwise known as your password. In the case of a domain controller, this big long password converted down to just 16 bytes. That encrypted output's known as the challenge response. It's sent back to the server as an authenticate message, and then the server forwards it off to the domain controller. Well, for our abuse attack, we can skip steps 5 and 6. We just need to get steps 1 through 4 working. There's a tool for that called Responder, and you can do coerced authentication. So people are familiar with things like the print spooler bug, the EFS coercion bug, the DFS coercion bug. There's a tool called Coercer we're going to abuse here to basically force a domain controller to authenticate to us so we can capture this packet. So the response, this is the fun part. So your 8-byte client challenge gets null padded out to 21 bytes. So this gets useful later on, which I'll show you in this little terrible eye chart. It leaves a third of the packet, not even have to be cracked. So we only have to crack 2 parts of this packet. So then you take an 8-byte server challenge plus the 8-byte client challenge. This becomes your session nonce. That session nonce is truncated down to 8 bytes. This becomes the NTLM version 1 ESS hash. The password's UTF-16 little endian encoded, MD4 to get the 16-byte hash, so it shrinks down dramatically. Then the password hash is null padded to 21 bytes. That 21 bytes is split into 3 parts. Now here's the cool part. Those 3 parts we just created become des keys. So we can do this attack basically where I've got the ciphertext, I got the plain text, I've got the ciphertext. I can then use that to go calculate the key using Hashcat. Back in the day, this used to take $1 million in hardware and about 24 hours. Now, thanks to the cloud and GPUs, we can do it in 3 hours for about $400. And back when the FPGAs were out, a $600,000 FPGA system could do this in 20 minutes. But we have GPUs, so I digress. The des key is used to encrypt the NTLM-v1-ESS hash that results in an 8-byte value. Those 8-byte values then concatenated to form a 24-byte value, aka the NT response. So when you're looking at responder, you get this reasonably opaque looking string. DC1's the username. Colon, it's blank. You get the domain, in this case it's EvilMog. You'll see this LAN Man response. Now there's 2 modes of NTLM version 1. There's one with ESS and one without. With ESS, or SSP, depending on what your software is written on, officially it's ESS, there is no server challenge that gets modified. It's based entirely driven by the client. So that means I can set a client challenge of 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and then use a rainbow table. With ESS, rainbow tables get defeated, which is why you have to use GPUs anymore. This is also why crack.sh stopped working for everybody, because we kept having to have the challenges changed. So this LAN Man response in the normal mode would just be basically a mirror or modified of what the NT response is to be full. But in this case, it's truncated down so we know it's using ESS. Next, we have this giant opaque blog, which I discussed in the last slide. Then we have our client challenge. Graphically, it looks like this. So we have at the top again, your domain controller password, 128 characters long, randomly generated. No human or no computer in the world is going to crack that in any reasonable length of time. It's impossible. But because it's truncated down to the 16 bytes, and that is password equivalent, that's all I need to know to DCSync your controller. We do our magic encryption, split it up into 3 chunks. You have your 7-byte chunks that get converted to des keys. You encrypt the client challenge. Out comes the ciphertext that creates the NT response. So if we're cracking that, we can just do this whole process in reverse with Hashcat. So here's the same thing with all these magical little values. So that's easily enough. So the exploitation of this is really simple. We're going to run responder. Technically, you don't even need the -fp. I throw it on because I'm lazy. So you run responder tech-i. Responder is a tool that basically says, it'll perform this client challenge authentication attack for you effectively automatically. Basically listens as a server, says anything that talks to me, give me your hashes. So you use the print spooler, EFS, DFS, and a number of the other coercion attacks, print nightmare, you name it. Then you use a tool called Coercer in a second window. You specify your user and a password. So you need a regular domain user. It could be any privileges you want, as long as it's got some kind of domain cred. You specify the target domain, in this case, the target IP, the attacker IP, and you collect the resulting hash. So you collect that hash. So in this case, you'll see that the challenge is still 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. Even though it's specified, that is the attacker challenge. The victim challenge or the server hash still gets modified, and that's why it's the LAN Man portion right at the beginning. You get cloned down my tool. All my tool is just basically a giant Python reformatter to make your life easy. So you run Python 3, NTLMv1-multi, tac NTLM, specify the hash. The tool's going to output a couple of commands. So you copy the commands from the tool. We create a hash file. You run a Hashcat. You specify the command in the tool. You wait 72 hours. If you're using a single GPU, or you buy a bunch on the cloud, spend your $600, and you come back, and there's your hash. But even 3 days, or 7 days, depending on how long it takes and what kind of GPUs you have, that's within the realm of a pen test, because your Windows passwords only change every 30 days. Oh yeah, please, thank you. So damn dry here. So much better. All right, there. Do I sound better now? Yeah, excellent. Hey, I was a trooper for trying. So nice, you do your GPU cracking, you get your hash back, and all of a sudden you've now popped the domain controller, because then you DCSync the controller. So we're going to go pull down Hashcat utilities. We're going to convert these des keys you cracked back into their NTLM parts. So we're in des to NTLM.pl, the first third, the second third, and then you crack the third third using the output from the tool. You combine these three parts together, and voila, you have an NTLM hash. You then run netexec using the domain controller account, collect all the hashes, all of a sudden you've owned the domain. Relatively simple. So the TLDR before I get to the demo is if you have NTLM version 1 enabled with the LAN Man compatibility level of 2 or lower, your domain's already compromised. It's that simple. So here's what the tool is. I swear to God, this QR code is not phishing. You know what? I don't want to commit crimes in the US because I'm Canadian, so no, it's not phishing. We're already in a trade war. I don't want to start a real war. And apparently I'm doing a demo now, so one sec. So damn dry here. All right. Let's see if my... All right, can everyone read my eye chart? Should I make this bigger? Cool. All right. So we're going to run responder. We have a specified interface, Ethernet 1. Now we're listening. Coercer. So in this case, we're running coerce with a user of user 1. The password of password exclamation mark, because user passwords are just about as good. My domain name of Mog, because I'm, kind of vain. My target is, the domain controller IP. Here's my local listener IP. Continue. And in theory, oh look, we have a hash. Looks like an NTLM version 1 hash to me. If I can copy and paste. Apparently computers are hard. Yeah, there we go. Command C. Stop this. So now, cd opt NTLM version 1-multi, Python 3, NTLMv1.py, NTLM paste. So if you look at the tool output, it breaks up what everything really means. But the important part is, create a file with this. It even tells you the commands to type, because we're all lazy here. I believe in copy and paste. So I create that, I type my commands. This says to crack with Hashcat. Well, in this case, it tells you the exact format to use the des character sets, but because I already have this cracked, because I have a time machine, -m 14,000, A0, 14,000.hash, des.canned. All right, so now, because we don't have a time machine, and you're not going to wait here for 72 hours, I mean, if you do, really, thank you all. Hashcat's doing its thing, and oh look, this thing has been mysteriously cracked. I wonder how that could have happened. It's like EvilMog planned this or something. So, now we're going to pull down the Hashcat utilities. Source. We need to convert des keys to NTLM. So there's part 1. And we're going to pull up part 2. And then I'm going to go copy this command. Opt hashcat utils src. We have part 3. So we're going to go export nt hash equals part 1, part 2, and part 3. That's 1, 2, 3 for the Americans. SMB 192.168.46.5. To prove this is my domain controller, first of all, yes, that's real. -u DC1 $h $NT hash. We're cracked. And now, for the coup de grace, that's the finishing blow for the rest of you. DRS, or yeah, NTDS. If I remember this correctly. Oh no, my domain controller might crash. There we are. We now have all the hashes cracked. And there you go. Now you'll know my real name while we're at it, too, because I put Dustin Haywood in there. So that was reversing NTLM version 1 to NTLM in about 15 minutes. That wasn't bad. Any questions?
The value inside of the hex
yeah.
bracket. Why does it do that?
So the reason for that is it's basically, it's not an ASCII value you're giving it, so it's going to be some weird des key and it can't render. So $hex means it is the raw format, and that was put into Hashcat around 2012 at my request, because it kept messing up our terminals when we were doing cracking. As a consequence, sorry, I'm talking outside the microphone. So he was asking about the Hashcat $hex format. That was put involved into Hashcat when we started cracking passwords that aren't UTF-7. So, you know, UTF-8, the weird, like, you can have a chicken for a password because the Windows passwords are UTF-16 the linear encoding. So your password could be like chicken emoji, poop emoji, cactus, for example, and not a problem. Consequently, if you want to piss off a hash cracker, make your password uppercase hex, bracket, and the random series of hex like dead beef bracket, we'll think our tools are broken. Also, put commas and semicolons into your passwords because it'll break the CSV your password winds up into when you get breached. Any other fun questions? Hashcat related, NTLM version 1 related. I'm here for the next 15 minutes or until they kick me off stage. No? Bueller? Bueller? Y'all old enough for that movie? Bueller? Yeah, Ferris Bueller's sick today, and he gave me the dry throat to go with, so thank you all very much. And by the way, this is used heavily. So the check your LAN Man compatibility level on your domain controllers. It is a separate policy from your regular domain policy. So your domain controllers could be set from back in the Windows 2000 days, for those of us admitting since that long, and never changed, even though your clients are up to the higher level. So make sure you check this. Also, certain vulnerability scanners might turn on older versions, like Nessus. So make sure they're not spraying credentials around in NTLM version 1 format, because that's a great way of capturing. With that, you are all dismissed. Thank you.